How do modern computers parse algebraic terms? Imagine trying to understand a sentence in a foreign language without knowing the grammar. That's similar to what a computer does when it processes algebraic terms. It breaks down the expression into smaller pieces called tokens, which are like individual words. These tokens can be numbers, variables like x or y, operators such as plus or minus, parentheses, or function names like sine or cosine. For example, in the expression 3x plus 2, the tokens are 3x plus and 2. The computer first scans the entire expression character by character to identify these tokens, simplifying the input into manageable parts. Once the tokens are identified, the computer checks if they follow the rules of algebra. This step is called syntax analysis or parsing. It uses a set of grammatical rules that define how terms, factors, and operators should be arranged. For instance, it knows that a number can be followed by a variable or an operator, and that parentheses must be properly balanced. If the expression is correct, the parser proceeds to build a structure called a parse tree or an abstract syntax tree. This tree shows how the parts of the expression relate to each other. For example, in 3 plus 4 times x, the tree will show that the multiplication happens before the addition, following the order of operations. There are different algorithms that help computers do this parsing efficiently. One common method is called recursive descent parsing, where the parser uses functions that call themselves to match parts of the expression to the grammar rules. It's like following a recipe step by step. More advanced algorithms like LL and LR parsers read the tokens from left to right and build the structure accordingly. LR parsers are more powerful and can handle more complex expressions, which is why they are often used in computer programs that evaluate algebraic expressions. Another helpful algorithm is called the shunting-yard algorithm. It converts the expression from the usual way we write it, called infix notation, into postfix notation, also known as reverse Polish notation. This format makes it easier for the computer to evaluate the expression without confusion about the order of operations. Once the expression is parsed and converted, the computer constructs a tree that shows the hierarchy of operations. This tree helps the computer evaluate, simplify, or manipulate the algebraic expression further. When the expression includes functions like sine, cosine, or logarithm, the parser recognizes these as special tokens. It then creates a subtree for the function's argument, like in sine of x plus y this way. The computer understands that the function applies to a specific part of the expression. This process of parsing algebraic terms is used in many areas. Computer algebra systems like Mathematica or Maple relying on it to manipulate symbolic expressions. Programming languages that include algebraic operations use parsers to understand and execute code. Educational tools also use parsing to analyze student input and give feedback. Understanding how computers parse algebraic terms can help learners see that algebra is like a language with rules. When expressions are written correctly, the computer can interpret and work with them easily. It's a fascinating process that makes complex algebraic ideas accessible and manageable for everyone.